And here we go. All right, so we are live. Hi everyone. Good morning to all the people out there. I know it's not morning for you all, but I still wish you good morning. Because maybe you know it doesn't hurt. So yeah, give me 1 second. All right. So hi everyone. This is Buffet Codes here. Today we have to do some rest. Okay. So thank you so much for joining in. Whoever will be joining me, right? So let me just reiterate. That today we'll be doing Rust. Okay. So we will be continuing to read the Rust book and then hopefully take it forward to something that we want to build. Right. So let's start with opening Chrome. So let me quickly open the there you go, that this is what we have. So now probably I can open the Rustlang book. All right, so let me go to the book and we can start. So what I want to start with today is to just go through what we had learned in the last stream. So we talked about structs, enums. So enums provide us a lot of different options, right? And structs are there as well. So one thing I really like is that you can have your own methods in enum as well, right? So that was good. Defining methods, we did see derived debug thing. How do you implement the methods for a struct? You can have multiple sections like impl rectangle, again impl rectangle, and have a different function if you want to, just put them differently. That's it. So enums and pattern matching, that I think, yeah, we did that, right? So that was good. So I think they have their inbuilt enum for IP address or something like that. So that they talked about it, right? So you can have you can match. That was good. So we did see about iflet. That was an alternative to match pattern, right? So that was good. So that is also done. Today what we want to, yeah, that is this seems to be very important, especially if you're doing Rust projects, right? But I sometimes find it boring to read about, how do you do this, but it's gonna come handy. So yeah, let's quickly read about it. Sorry, I have my phone alarm mode on, so let me quickly fix that. All right, it's good, I guess. Yeah, there you go. All right, so what do we have? As you write large programs, organizing your code will be important because keeping track of your entire program in your head will be, yeah, impossible. Right, so in addition to grouping functionality, encapsulating implementation details, let's say reuse your code at high level. Right, once you've implemented an operation, maybe you would like to, get it as a module and then start reusing it wherever you can. So packages and crates, the first parts of the module system will cover our packages and crates. A package is one or more crates that provide a set of functionality, right? So it's like a package will or might contain one or more crates. A package contains a cargo.toml file that describes how to build those crates, right? So a package contains a cargo.toml file. So that is what we need to build. So for example, if we start a new project, that automatically has a cargo.toml, right? So a crate can be a binary crate or library crate. So usually we see that if you create a project, you will have src/main.rs, right? But if you want to create a library, it will have src/lib.rs, right? Because then it will not be executable. So binary crates are programs you can compile to an executable that you can run, such as command line programmer server. They must have a function called main, yeah, that defines what happens when the executable runs. So all the crates we have created so far have been binary crates. That is true, so, right? So that's what I talked about, right? If something is executable, that is called a binary crate. But if you don't have a main function which is not meant to be executable, right, then you can call it a library crate and make sure that you have src/lib.rs, right? Is it required that it needs to have that file name? I'm not very sure, but we'll see. So the crate root is the source file that the Rust compiler starts from and makes up the root module of your crate. Several rules determine what a package can contain. A package can contain at most one library crate. Okay, right? So a package can contain at max one library crate. It can contain as many binary crates as you would like, but it must contain at least one crate, either library or binary. So it can contain multiple binary crates, but it can only contain at max one library crate. So let's walk through what happens when you create a package, right? So when you do this cargo new my project, it creates a cargo.toml file and it creates a main.rs file in src folder. So by default, it is a binary crate. So when we enter the command, cargo created a cargo.toml file, giving us a package. Looking at the contents of cargo.toml, there is no mention of src main.rs because cargo follows a convention that src slash main.rs is the crate root of a binary crate with the same name as the package. Likewise, cargo knows that if the package directory contains src slash lib.rs, package contains the library crate with the same name as the package. Okay, so awesome. That sounds good. So that means you need to have src slash lib.rs for a library crate. Cargo passes the crate root files to the C, that's the compiler, to build the library of binary. So here we have a package that contains src slash main.rs, meaning it only contains a binary crate named my project. If a package contains src slash main.rs and src lib.rs, it has two crates, a binary and a library, both with the same name as a package. A package can have multiple binary crates by placing files in the src bin directory. Each file will be a separate binary crate. Interesting. That is good. So defining modules to control scope and privacy. In this section, we'll talk about modules and other parts of the module system, namely paths that allow you to name items, the use keyword that brings a path into scope, and the pub keyword to make items public. We'll also discuss the s keyword, external packages, and the glob operator. Okay. We're also going to start with a list of rules for easy reference when you're organizing your code. All right. So there are some rules that they have given us when you're creating your own package and all, right? Because it's important that they set the standard. So here's how modules, paths, the use keyword, and the pub keyword work in the compiler. So start from the crate root. When compiling a crate, the compiler first looks in the crate root file using src slash lib.rs for library crate. Okay. So they start with these root files, right? lib.rs or main.rs. Then declaring modules. In the crate root file, you can declare a new module named say garden with module garden. The compiler will look for the code inside the module in these places. Okay, so where will it look for the garden module, right? It will first go for inline. So wherever maybe in the same file garden is implemented within curly brackets instead of semicolon. So here you can see there's a semicolon, right? I'm not sure if you guys can see this, but there's a semicolon, right? So what they mean is that maybe they have a curly bracket instead of semicolon, which means that they have defined it there itself inline. They'll also look for src slash garden.rs, right? That's where the module can also be, and src slash garden slash mode.rs. Okay, cool. So if you have a folder for garden, then you need to have mode.rs where the module is defined. Declaring submodules in any file other than the crate root that's being compiled as part of the crate, for example, src slash garden.rs, you can declare submodules. For example, mode vegetables. So they are in any file other than the crate root that's being compiled as part of the crate, right? So you can declare submodules as well. The compiler will look for the code inside submodules in these places within a directory named for the parent module. Okay, so inline again, yeah, it can be inline, and then you have okay, interesting. So in the src slash garden.rs, you can have more vegetables. That means it will look for src slash garden slash vegetable.rs, or again it can also have submodules. So maybe it is in a folder, and then you have more.rs. So paths to code in modules. Once a module is being compiled as part of a crate, you can refer to your code in that module. For example, in asparagus, type in the garden vegetables module from anywhere else in the crate by using the path crate scope operator garden, scope operator vegetables, scope operator asparagus, as long as the privacy rules allow. Okay. Right. So for example, if you have already compiled vegetables.rs as part of your crate, so you can refer to that particular module in any of your code wherever. So that, but it needs to be in the same crate, right? By using this path crate. So it starts with crate, and then you can have modules, submodules, and all of that. So private versus public. Code within a module is private from its parent modules by default. To make a module public, declare it with pub mode, okay, instead of mode. To make items within a public module public as well, use pub before their declarations. Interesting. So by default, they are private. But what you need to do is, if you want to make them public, use pub. The use keyword within a scope, the use keyword creates shortcuts to items to reduce the repetitions of long paths, right? So for example, here, This was really long. So this was really long. So you can create a shortcut with use this, and then you can directly use asparagus. So here's a binary crate named backyard that illustrates these rules, right? So for example, the binary crate name is backyard. Then you have cargo.toml file. In src you have main.rs. Then you have garden.rs, which is module, and in garden you have a submodule called vegetables.rs. Right, so how do you do that? Use create garden vegetables asparagus pub mode garden, let plant equal to asparagus. I'm going plant. The pub mode garden means the compiler includes the code it finds it in src/garden.rs, which is so they have both. So in src/garden.rs they have pub mode vegetables. So they made it public, means the code in is included too. There you go. This is also public. Now let's get into details of these rules and demonstrate them in action. Yeah, what I want to do is before this, okay, so let's try to make this thing right. And what if I don't include pub there? So let's go. Is it day 3? Yeah, I guess. Cargo new, let's call it backyard. And if I do src main.rs, I have it here. Yeah, there's a bug in Rustler Analyzer right now. I need to fix it. Anyways, for now this will work. So let's do this. So let's assume that we have use create. We will create a garden crate. Right? What is it? Create garden vegetables, asparagus, something like this will have, right? And then we will have println we are growing, something like this. So all I'm trying to do is whether this will work or not, right? So if I do asparagus, what if I do this? Right, so here basically they had asparagus as what? They had this as a struct, right? What I want to do overall is probably keep it a function that returns a string. So that's also fine, right? We can do that. And here we should do mode garden, right? And once this is done, we will do src/garden.rs, which contains the implementation, right? And here what we're gonna do is mode vegetables, right? And then we're gonna go to mkdir src/garden and then do vim src garden vegetables.rs. And here what I can say is, yeah, I need to fix this Rust analyzer today. I mean, I'm not gonna fix it. I'm just gonna update probably. So what I can do is I can have a function asparagus. Thank you so much ffjoes13 for joining in. I understand you are a spam, but I appreciate that. It's always okay. So this is what I have here. So that was just a suggestion they had. Cool, this is okay, right? So now what I can do is, yeah, I don't need to derive it for now. So you see, so if I go to src main.rs, oh god, now I can just, so wherever I have used asparagus, that should be working. Now this is what I wanted to see, right? So here it says that module vegetable is private, right? So by default this was private. Now what we can do is we can go over, I think we can go over garden and we can try making it public. Will it work then? Now this asparagus is also private, so you need to do pub function because we're using it outside the scope. the following trait is not implemented, but okay, but not in scope. Perhaps add a use. Okay. So they want use std from. Is this what you want? No, right? Std. Okay. Will this work? Oh, what did I do? What's wrong here? Found struct. Okay, use std stir from stir. Okay. Expected string because of return type. Mismatch types. Expected struct string. I don't know what was wrong. So sorry, passes a string s to a return value of this type. So it's a result. Okay. Right. So if you have a star and you want to convert it into a string object, then you do unwrap, which is not probably safe. So yeah, that makes sense. Okay. So we have hey, and then we do unwrap. Okay. This is okay. So will this work? How do I run it? Is there any way to run this? I don't know. I mean, inside the terminal. That's what I meant. So it works, right? So I didn't have to make it public necessarily. But if I had done that, my question is, will it work? No, right? So you need to make them public. Cool. So this is good. All right. So this is done, right? So we had just a quick walk through the code example. Now what they're saying is grouping related code in modules. Modules let us organize code within a crate into groups for readability and easy reuse. So modules also control the privacy of items, which is whether an item can be used by outside code or is in internal implementation detail and not available for outside use. Okay. As an example, let's write a library crate that provides the functionality of a restaurant. We'll define the signatures of functions but leave their bodies. Okay. I don't need to look at this right now. So yeah, this is important. Create a new library named restaurant by running cargo new -lib. That's how you create a library, right? And that's it. So what they've done is they have a mode and they have defined it inline. Okay. So that is how they're doing it. So they have mode front of house, which is again inline and hosting in the serving. So they have these functions, but they just have the signatures for now. So they define a module by starting with mode keyword and specify the name of the module, then put curly braces to implement it there itself. They do it for hosting and serving as well. Now what's next? What they're doing? By using modules, we can group related definitions together, name why they are related. Programmers using this code would have an easier time finding the definitions. Okay, makes sense. So this tree shows some of the modules nest inside one another. Okay, so they have create, front of house, hosting. So that doesn't mean, so this is just a structure what we have here, right? But this does not mean that this is how the file structure looks like, right? Please don't, those are two different things. Now paths for referring to an item in the module tree. To show us where to find an item in a module tree, we can use a path in the same way as we use the path when navigating a file system. If you want to call a function, we need to know its path. So a path can take two forms. First is an absolute path starts from a crate root by using a crate name or literal crate. A relative path starts from the current module and uses self, super, and identify in the current module, right? Both absolute and relative paths are followed by one or more identifiers separated by double colons. So let's return to an example. So that's what they were doing here, right? So how will they So for example, we have a public function eat at restaurant, right? And if we want to access add to waitlist in the module front of house, and which is, sorry, in the module hosting, which is inside the front of house module. So how you do that? There are two options you have. First of all, you can use absolute path, which makes sense, and the relative path, because this front of house is in the same file, right? It's accessible here, so you can actually do front of house and hosting and add to waitlist. That also works. So this is okay. I think we are all good here. Our preference is to specify absolute paths because it's more likely we'll want to move code definitions and items called independent of each other. That makes sense, yeah. Now it fails because hosting is private. Yeah, right. That's what we saw, because by default these are private, right? So module hosting is private, and that means you cannot access private module. So the error messages say that module hosting is private. So we have the correct paths, but those are private, right? So modules are not useful only for organizing your code. They also define just privacy boundary. The line that encapsulates the implementation details external code is not allowed to know about, call, or rely on. So if you want to make an item like a function struct private, you put it in a module. Okay. So let's say by default I want to make something private, put it in a module. Okay. That is interesting. The way privacy works in Rust is that all items, functions, methods, structs, enums, modules, and constants are private by default. Outstanding. Consistency. See, like everything is private, so you don't need to worry about it, right? You just put pub in front of each and everything if you want to access them outside the scope. So items in a parent module cannot use the private items inside the child modules. Items in the parent module cannot use the private items inside the child module, but items in child modules can use the items in the ancestor modules. That is okay. The reason is that child modules wrap and hide the implementation details, but the child modules can see the content in which they are defined. Yeah. So it's like everything is open. Like children can ask any question to their parents, but parents cannot ask everything to their children. So Rust chose to have the module system function this way so that hiding inner implementation details is the default. The way you know which parts of the inner code you can change without breaking out a code, but you can expose that way. Okay, but you can expose inner parts of child modules code to outer and system modules by using the bub keyword, right? So that's, you always have an option. It's not like there's no way around it. So let's return to the error. They made it public hosting, and this function needs to be public as well. Is it? Yeah, there you go. This also fails because you need to make it public. So adding the pub keyword in front of mode hosting does not make everything inside it public as well. It just makes the module public. That means you can access the hosting module now. But if you want to access anything, any method inside that, you need to use pub. So that's what they have done here. Now the code will compile, right? So best practices, we mentioned a package can contain both src main.rs binary crate as well as lib.rs library crate, and both crates will have the package name by default. Typically, packages with this pattern will have just enough code in the binary crate to start an executable that calls the code with library crate. This lets other projects benefit from the most functionality that the package provides because the library crate's code can be shared, right? The module tree should be defined in src lib.rs. Then, give me 1 second, guys. Yeah, I think all is okay. Right. By the way, guys, if you're here, don't hesitate to say hi. Right. It's very early morning for me, 6:21 a.m. So I'll appreciate any good mornings over here from my viewers. I mean, I have 43 followers, so I don't have a lot. It's okay. That doesn't matter. Just keep continuing. So starting relative paths with super is also an option. Yeah. So by the way, that note was just a quick note to everyone who is using this, that it's generally a good practice to keep your, if you have both library crate and binary crate, it's good to have main.rs as short as possible, which just calls the library code, right? So we can also construct relative paths that begin in the parent module by using super at the start of the path. This is like relative starting a file system with path dot syntax. Oh, is it? I mean, that's how they use super here. Consider the code here, right? So, okay, super scope operator, right? So for example, back of house, you have fixed incorrect order. So if you want to access delivery order, you can directly do super and scope operator. That means you go back to the main module and you access delivery order. This is the first time I've seen this, to be honest. The function fix incorrect order defined in the back of house module calls the function deliver order Hmm. But will it work without it as well, right? Like, because, oh, this is private, but this is private, right? But you can access from the parent module. The child module can access anything from the parent module, right? So we can use super to go to the parent module of back of house, which in case is create the root. From there we look at the deliver order and find success, right? We think back of house module and the deliver order function are likely to stay in the same relationship to each other and get moved together. Should we decide to reorganize the creates module tree, right? So what they mean is, so we can assume that the relationship between this incorrect order and deliver order is going to be the same, that this fixed incorrect order will have this deliver order as one of the parent functions. Making structs and enums public, we can also use pub to designate structs and enums as public, but there are a few extra details. Okay, if we use pub before the struct definition, we make the struct public, but the struct fields will still be private. Yeah, we can make guys, is the video buffering? I don't know. Okay, please do let me know if anyone is here. I don't know, this Twitch had this warning here. Okay, warnings are made to be ignored, right? We make the struct public, but the struct fields will still be private. We can make each one of them as public. We have defined a public back of house breakfast struct with a public toast field but a private. Okay, so you can do that. This models the case in a restaurant where the customer can pick the type of the bread that comes with the meal, but the chef decides which fruit accompanies the meal. Yeah, too many real life examples, Rust. That's too much. Come on, chill out. So for example, you have the struct as public, then you have toast as public, and seeds of fruit that the chef will decide. So you don't need to worry about it, right? So there you go. So they have hard coded it to peaches. I don't eat them. Now meal or toast equal to string from wheat. So I see. I didn't have to do from stir, is it? This would have worked. Damn, bro. All right. So that is good. Hmm. I see. Also note that because back of house breakfast has a private field, the struct needs to provide a public associated function that constructs an instance of breakfast. If breakfast did not have such a function, we could not create an instance of breakfast in eat at a restaurant because we could not set the value of the private seasonal fruit. Interesting. That makes sense because anyhow, you need to set this value if you want to create an instance of breakfast. And since this is private, that means any user cannot directly do that. So if you want to create, you can have impl breakfast public function summer, which returns a breakfast type, and you provide the toast. So that's what they have done. That you don't create an instance of breakfast directly by using the parenthesis. You do scope operator summer, right? And that's how you do it. That is good, right? Um, cool. All right. In contrast, if you make an enum public, all of its variants are then public. We only need the pub before the enum keyword. Okay, so that is how they differ. Because we made the appetizer enum public, we can use the soup and salad variants. See directly now they have used it. Enums aren't very useful unless the variants are public. It would be annoying to have to annotate all the enum variants with pub in every case. Yeah, that makes sense. There is one more situation involving pub that we have not covered, and that is our last module system feature, the use keyword. We'll cover the use by itself first, and then we'll show how to combine pub and use. Sure. So let's go to bringing paths into scope with the use keyword. So it might seem like the paths we have written to call functions so far are inconveniently long and repetitive. For example, yeah, all right, all right. So in listing 711, 711 is this one. We bring the crate front of house. So crate is the root crate, right? Whatever you had by default. Then you have front of house defined here, the module, and then you have hosting inside it. That's another sub module. Right. So we only have to specify hosting add to waitlist to call to the add to waitlist function in eat at restaurant. Yeah. Okay. So now what they did is to get rid of all the stuff they have done, they did use create front of house and then they did hosting. That means you can actually use hosting and scope operator add to waitlist. Adding use and a path in scope is similar to creating a symbolic link in the file system, right? So I think we have, for those who are coming from C++, have at least a basic idea of what they mean here, right? So this looks good. Note that use only creates a shortcut for the particular scope in which the use occurs. Listing 712 moves the edit restaurant function to a new child named restaurant, customer, right? That is what they have done here in customer. Now this compiler will fail. That shortcut no longer applies to the customer module. Okay. So use was used in this basic in the particular scope which is not in the inside this customer, right? So use of undeclared create or module hosting, right? That's what they mean. Notice there's also warning that use is no longer used in this scope, right? To fix the problem, move the use within the customer module to or reference the shortcut in the parent module with super hosting within the child customer module. Yeah. Creating idiomatic use pass. Okay. Idiomatic. What do you call it? I call it idiom. So idiomatic. You might have wondered why we specified use create okay and then called hosting add to waitlist in eat at restaurant rather than specifying the use path all the way. That is not a good idea, right? People need to know where is it coming from, because let's say, yeah, exactly, right? So if you would have done use stored collections Hashmap and new, and then you would have called new here directly, that would have meant, right, that people will not know where is it coming from, right? Like, is it hash maps new, is it something else is new? So people will not know about it. So there is no strong reason behind this idiom. It's just a convention that has emerged, and folks have gotten used to reading and writing Rust code this way, right? Exactly. It's the same thing about namespaces in C++, right? If people do stored cout, stored, for example, maybe stored max, stored min, it's just helpful sometimes, right? But stored cout maybe not, because cout is mostly people are aware that it's in the stored namespace. But yeah, so the exception to this idiom is if we are bringing two items in with the same name into the scope with use statements, because Rust does not allow that. So this listing 715 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. So you have use stored format and IO. Now you can use them modules. So modules for modules is okay. Using parent modules distinguishes the two result types. If we instead use specified, yeah, then it would have been difficult. Yeah. Providing new names with the S keyword, that is okay, right? So input numpy is NP. So this is nice that they have followed the convention here. Alright, so this is cool. Then we have re-exporting names with pub use. When we bring a name into scope with the use keyword, the name available in the new scope is private. To enable the code that calls our code to refer to that name as if it had been defined in the code scope, we can combine pub and use. That is interesting. So if you would have done use create front of house hosting, and then we had function eat at restaurant, and then we do hosting add to waitlist, what was wrong? So this technique is called re-exporting because we are bringing an item into scope, but also making that item available for others to bring into their scope. Before this change, external code would have to call add to waitlist function by using the path restaurant, front of house, hosting, and add to waitlist. Now that is pub use has re-exported the hosting module from the root module. External code can now use the path restaurant, hosting, add to waitlist instead. Re-exporting is useful when the internal structure of your code is different from how programmers calling a code would think about the domain. Yeah, I think we'll have more examples on that later on. But what they mean is, suppose this is in srclib.rs, right? And let's say this is a restaurant scope. Then you would have to do restaurant hosting, front of house hosting, and that's how you would have used it, right? And then you do add to waitlist. Now, what you don't want to do is, you don't want to have restaurant and then front of house. You just want to have restaurant hosting, add to waitlist. So you can do pub use, create front of house and hosting, and then you can directly do hosting, add to waitlist, which makes sense for some use cases, right? Where you don't want the users to have these different scopes available or visible to them, just to only confuse them, right? So far, all the examples this chapter define multiple modules in one file. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. For example, let's start from the code listed in 717 and extract modules into files instead of having all the modules defined in a create root file. Right, it's always a good idea to have things separated. Right, that makes sense. First, we'll extract the front of house module into its own file. Sure. So they have it here, src-lib.rs. So leaving only front of house declaration, so that src-lib.rs contains the code shown over here. Note that this will not compile until we create src front of house.rs file. Yeah, makes sense. Here this is just using it, right? That's all it is doing here. So next place the code was in the curly brackets. There you go. Note that you only need to load the contents of a file using a mode declaration once somewhere in your module tree. Once the compiler knows the file is part of the project and knows where in the module tree the code resides because of where you have put the mode statement, other files in your project should refer to that code in that file using a path to where it was declared as covered in the paths from referring. Yeah. Alright, so next we'll extract the hosting module. Okay, all of this is fine. I don't think we need to worry about it. So this section covered the most idiomatic file paths the Rust compiler uses, but an older file path is also supported. For a module named front of house declared in the create root, the compiler will look for the module's code in right, here and here. Now for a module named hosting that is a submodule of front of house, it will look over here and here. So this is also supported, but it says older, still supported path. If you use both for the same module, you'll get a compiler error, which is good. Using different styles for different modules in the same project is allowed, but might be confusing. The main downside to the style that uses files named mode.rs is that your project can end up with many files named mode.rs. Yeah. You have seen this, right? That is good, because suppose if you're in a Visual Studio Code or Vim editor and you're like just searching for the file for mode.rs, you'll see so many. And I think it happens with TypeScript or JavaScript code usually, that you have index.ts file, for example, and then you have these, so many classes having these index.ts file. Even with Python, right, you have, yeah, you can have main.py for each class or module. Sorry. All right, so this is good. So this is done. We are done with chapter 7. This is great. Now we have common collections where we need to go through storing list of values with vectors, storing UTF-8 encoded text with strings, storing keys with associated values in hash maps. And then we'll go to error handling. Then we'll go to chapter 9, 10. So by the way, I had done all of them before. So right now it's been quite some time since I did some Rust. What is happening? Why can I not scroll down? Which one is buggy? Is it my Chrome or is it there? It looks like something is buggy with their scroll bar. Okay, that's okay. I hope so. I mean, not that I want them to have bugs, but I just don't want my Chrome to have bugs right now. All right. Okay, so what's the time? We have 6:35. How long I've been streaming? 38 minutes. Just still not good enough, guys. We need to work harder. Not as in terms of the streams, but yeah. So let me quickly have a drinks break and then we'll be back. Give me 30 seconds, I guess. All right, so we are back. That was hopefully less than 30 seconds. All right. So we have common collections here. So the standard library includes a number of very useful data structures called collections. Most other data types represent one specific value, but collections can contain multiple values. So unlike the built-in array and tuple types, the data these collections point to is stored on the heap, which means the amount of data that does not need to be known at compile time can grow or shrink as the program runs, right? So just by default, just for information, everything in collections is stored on heap. That's what they mean, right? I hope so. Now, each kind of collection has different capabilities and cost, and choosing an appropriate one for your current situation is skill you will develop over time. Yeah. So we have a vector, we have a string, we have a hash map. So vector allows you to store a value of number. Yeah, I mean vector is a vector. A string is a string. Yeah, I know. It's a collection of characters. Yeah, we mentioned the string type previously, but in this chapter we'll talk about it in depth. That is good. A hash map allows you to associate a value with a particular key. It's pretty useful. I think I've seen the use of hash map a lot. To learn about the other kinds of collections provided by the standard library, see the documentation. Now, how do you store list of values with vectors? You do let v. So this is what we have as like generic type t. You can mention the type i32 and it will automatically create one for you. So note that we added a type annotation here because we are not inserting any values into this vector. So you need to, right? If you had this thing, uh, if you would have just passed the values 1, 2, 3, it would have automatically known that, yeah, just give it the default i32 type, right? So more often, I think mostly people use this thing, which is a macro, which is basically same as using vec i32 here, right? Sorry, vec t here with initial values. Okay. Rust conveniently provides a vec exclamation mark macro. What do you call it? Vec bang. So I think people call this exclamation mark as bang as well. All right. So this does the same thing as you would have done here. Just push 1, 2, 3. So you can also do v dot push, which is yeah. Okay. Right. I think they're just saying that, whatever you have seen before, it also applies to vectors. So when the vector gets dropped, all of the contents also dropped, meaning those integers it holds will be cleaned up. So this may seem like straightforward point, but it can get complicated when you start to introduce references to the elements of the vector. So reading elements of the vector, there are two ways to reference values stored in a vector: via indexing or using the get method. So shows both methods are accessing a value in a vector with indexing syntax and the get method. So you can also index the third element is this, and you can also do dot get, which will return something of type result, right? No, option. Sorry, it returns something of type option. It can be a sum, it can be a none, right? Yeah, there you go, option. First, use the index value of 2 to get the third element because vectors are indexed by number starting at 0. Second, we get the third element by either using ampersand and this, which gives us a reference, or using the get method with the index passed as argument, which gives us an option t. Again, a reference t, right? So the reason Dutch provides these two ways to reference an element is so you can choose how the program behaves, right? So if it does not exist, you can have something of your own. There's no such element. Sorry and all. Whatever. That is good that they provided, right? I mean, nice. So when we run this code, the first square brackets method will cause the program to panic because it references a non-existing element. This method is best used when you want a program to crash if there is an attempt to access element past the end of the vector. So when the get method is passed an index that is outside the vector, it returns none without panicking. You can use this method if accessing an element beyond the range of the vector. May happen occasionally under normal circumstances. Your code will have that logic to handle having either some or none. Yeah, makes sense. So when the program has a valid reference, the borrow checker enforces the ownership and borrowing rules. To ensure this reference and any other references to the contents of the vector remain valid. Right, that makes sense. So you see what they have done here. So we have let mute v equal to 1, 2, 3, 4, 5. You did ampersand v of 0. This is the first you got, right? Now what is it doing? It's trying to, it doesn't, so this first does not hold 1. It holds the address to 1, right? That is it, right? And this is immutable borrow. That rule applies in listing 8n. So yeah, they talked about it. Recall the rule that states you cannot have mutable and immutable references in the same scope. Oh yeah. So they had this immutable borrow is occurring here. Immutable borrow is occurring here. The code listing in 8.7 might look it should work. Why should a reference to the first element care about the changes at the end of the vector? This error is due to the way vectors work. Because vectors put the values next to each other in the memory, adding a new element onto the end of the vector might require allocating new memory and copying the old elements to a new space. Yes. If there is not enough room to put all the elements next to each other where the vector is currently stored, in that case the reference to the first element would be pointing to a deallocated memory. The borrowing rules prevent programs from ending up in that situation. Now iterating over the values in a vector, right? So that makes sense, right? So that's what they're saying, because what happens, let's say if the capacity of this vector was only 4 elements, let's say, and if you try to push a fifth element, now it doesn't have enough space, so it will try allocating a different block maybe, and then this whatever address it was storing, it was pointing to, will be deallocated, right? So it will be freed and you will not be able to access it. That's why it was not working. Hmm. Iterating over the values in the vector, you can do for I in. So this is equivalent to dot to iter, I guess, into iter. To access each element in a vector in turn, we should iterate through all the elements rather than just use indices. We can iterate over immutable references to each element in a mutable vector in order to make changes to that element, right? So let's say we have a mutable vector, and if you do create, you iterate over the mutable references, that means that you can do star I. So because this I is an address, so you can dereference it and you can do plus equal to 50, right? To change the value that the mutable reference to, we have used a dereference operator to get the value I, and before we use the plus equal to operator. So using an enum to store multiple types, you can have these enums here, and you can have vector of spreadsheets cell int and takes an I32, F64 and string. So that's what they have done. Oh, so vectors can only store values that are the same type. This can be inconvenient. There are definitely use cases where you want of different types, right? So that is possible through enums. All right. So that's what they're just saying, that there are different methods as well, and you can go to the documentation to read more about it. There's a pop method as well, which essentially removes the last element and returns it as well. Right. I think in some programming languages and standards, pop just pops. Right. So people have to do top first to get the last element and then pop it again. So we've talked about strings before. What is a string? Yeah, I don't know, for some reason I don't feel like, I feel like I don't feel like studying strings today, because I think I've done this before, but I'll read over them again. So that's okay. But not today, guys. I think I'm gonna stop here in terms of what we're gonna do. So we did study the chapter 7 and chapter 8.1, right? What I wanted to do was today write some Bismuth code, probably make some progress. So yeah, I'm gonna stop here, right? And then we'll come back to reading rest of the parts, because understand, right? Like every chapter as we move along is gonna be a lot of theory, a lot of information that comes into our mind, comes in, that we'll have to read. It's just getting probably more difficult as we move on. And in terms of like what is getting difficult to continue completing 2 chapters in a day, that is just, in a single stream. I might do it offline, but I will try to still walk through over the stream. All right, guys. Still a lot to cover, right? But yeah, this does not stop us to start writing code. So maybe one day we'll just, once we feel confident about it, we can start doing it. All right. So that was it for today. It was a short stream. It's good to have short streams, I guess. It helps you to stay focused. I might stream about Bismuth just after this. Um, we'll see. I don't know. I want to work now. So yeah, maybe. Or we can do some Bismuth, right? Right. All right, guys. So that is it. I'm gonna start another stream now, and we will do some KD dialing me to manager boarding. Thank you so much for joining in. Good morning again. It's still a good morning. Right. Take care, everyone. Bye.